So let us get started, shall we? I don't know if anyone's around. Sorry, one second.
About an hour.
Sorry about that. Yeah, let us, start talking, because I know you guys are here, or at least one person's here. And I can go check the chat. Oh, no, more than one. Hello, Gypsy. Hello, Atakeen. Let us get my chat popped out so I can see everything. And we can get this ball rolling. Now, yesterday wasn't the best stream. I know that much. The longer it went, the more I was distracted by the code I was producing, trying to get things done, and honestly, there's illness going around, so I'm not feeling the sharpest. Sorry. I see myself on the thing, and it just bothering me. But yeah, what a crazy week it's been so far, honestly. Forgive me for my voice not sounding the best. I am still trying to get my throat to, you know, stop scratching. Yeah, yesterday we went over some basics. We started discussing exactly what a blockchain is, which, as the code I showed you was demonstrated, it's actually something very, very simple at its basest format. It's just a bit of data, and then a bit of more data with the hash of the previous data included in it, hashed. And with every hash, the chain gets stronger because you are not only validating the latest data, but the data that came before it, and with that, the data that came before that, with that, the data that came before that. In fact, I think I've got a good image to show, just to visualize what I had a good image, and now I've lost it. To visualize just what a blockchain looks like. There's, where is it? There we go. Image. Where did I save that? No. Let me just grab this for you guys right quick, because I don't actually know where I stuck it. Where's it saving? Oh, downloads, that's why. Alright, so it's not the most user-friendly image, but so essentially you've got a block, the block is hashed, and then the hash of that block is referenced in the previous hash, and then this block is hashed with the previous hash, meaning that you're getting a hash not only of this data, but this data and the hash of this data. It's recursively self-validating. And if this data changes, this hash will change, and thereby this hash will change, this hash will change, and so on. So it's very easy to find the first place where data has been manipulated or changed using it. All very straightforward, simple stuff, although it can get pretty complex pretty quickly, as you're going to see today, because we are going to be getting into the nitty-gritty of more complex parts of the blockchain, such as decentralization. Now, first and foremost, you know, having a chain of data that is absolutely verifiable is wonderful. I would say it's groundbreaking if the ground hadn't already been broken, you know, 10, 15 years ago by Git and Bitcoin and other services that have used the blockchain. Have used a blockchain, I should say. However, that alone does not give it its strength. It gets its strength mostly from... Excuse me, I'm so sorry, my throat is just... I'm dropping everything today. My throat is torn up. And I need something to smooth it out. A soft drink. Hello, Lady Justice. Hello, everyone. I know I just shared this out, and I'm just kind of rambling at this point, but just validating a block... By the way, I did fix this in our tests last night. After the stream, I was able to figure out what I did wrong, which was essentially... This doesn't need to be too string, does it? I'm not sure. Let's see if it throws a fit. I mean, I could have sworn the tests were passing last night. Oh, you know what? I was working on my laptop. I need to update the code. So, git pull. And we are going to update our blockchain of code in the process. As you can see, 2 removals and a bunch of additions, 4 removals and a bunch of additions. This is one of those things that blockchains are really efficient at. Not only can you see if everything's changed up to a certain point, you can identify specific changes and use those changes as the difference between 2 blocks. It's very efficient and beautiful. I love this. But are we still passing is the question after updating. Because I did change these files, you may notice that calculate hash and hash no longer have toString at the end of them. And I've even added in an isValidChain function, which is going to be part of our distribution model. Where's the tests for it? So I had to go through and make sure that if we changed hashes in the chain, that it would invalidate the chain, which it absolutely does. So we're now passing 5 sets of tests. And we have full coverage of our code, which makes me very happy. But what comes next is a little bit more complex. Let me find my reference document that I'm using. No, not that. I'm using like 4 or 5 different code bases to sort through and write this stuff. What we're going to be doing is adding in now is WebSockets, yarn add WebSockets, express. I don't know. I might need body parser, I'm not sure. Let's just add these for now. Just super quick, simple shits. In order to assure that we have what we need next, because what we need next is literally a web server. Or, well, not specifically a web server so much as a... well, a web server, yes, but also a WebSocket server for peer-to-peer access. We're going to be doing this by having us import Express from Express. We're going to import WebSocket from WebSockets. And now we're going to define some ports. Var HTTP port equals process.env.h toy blockchain HTTP ports, or our install of the packages is done, or we're going to start on 3000s. Var P2P ports equals process.env.toy blockchain P2P ports, or 6000s, and var initial peers equals process.env.toy toy blockchain peers, or wait, no, is either if we have toy blockchain peers in our env, we're going to process.env.toy blockchain peers dot split by comma, and if that's not the case, we're just going to have an empty list. And why is that so mad at me? Oh, that's why. I'm using vars. Const and let. Now, initial peers is eventually going to change. I don't know why you're mad still. Express is defined but never used. WebSocket is defined but never used. Oh, this is supposed to be WS, not WebSocket. Alright, that cleans that up a bit. And these variables are never used. That's fine. So essentially what we have here is this is called a tertiary operator, and if toy.blockchain.peers exists, we're asking if it exists with this question mark. If it does exist, we're going to set initial peers to process.env.toy_blockchain_peers, and we're going to split that with commas, turning a string into an array. I can show you how that works here right quick. So let's say we've got a string of peers. 192.168.7.1, 192.168.68.7.2 dot splits, comma, returns an array with our two IP addresses. And that's essentially how we're going to do this, although this is a bit of a pain in the ass, and we're going to get into why later. I do not like having my peers hard-coded in. Unfortunately, you can't escape that. You really can't escape it. The closest we can come is to... Good morning, Vladiro. I just saw your message. Glad to see you. How's Toronto doing? But yeah, there's a big problem with distributed systems, and that is you have to know where to go first in order to get a list of peers. Now, one way of doing this is by putting a decentralized list of primary peers up on IPFS or a torrent, and then having the client download that. That's a little too complex for what we're doing here today. So instead, we're just going to pass it in via the... we're just going to pass... It's going to... Essentially what we're going to do is we're going to say toy blockchain chain peers equals 192.168.7. I think it's 134. 192.168.7.178, blah blah, whatever it is, and then node lib main.js. Now we don't have a lib directory yet. Oh wait, no, it'd be dist_bundle.js. Dist_bundle.js. We don't have our bundle to run yet. However, as soon as we do, this function will work. That said, we need to actually get there. I guess this can be a const, because while we... Yeah, okay. Now we need a const sockets equals... We need a web server. Let's init HTTP server equals var app equals express. No, hold on. Const app equals express. App, we need a body parser, don't we? We do need body parser. Import body parser from body parser. Yeah, we're going to be getting a ton of problems until our code is cleaned up because none of it's used. Yarn add body parser. App.use body parser.json. And that's just a basic middleware that will translate JSON from a string into something a little more visible. Easier read, I should say. App.get blocks is going to have a request and a response, in which the response sends JSON.stringify. We don't have our blockchain set up. Blockchain. Import blockchain from blockchain. We're actually going to make this blockchain do something for us. So const sockets and const blockchain equals new blockchain. Alright, now this app.get, essentially what it's doing is it's going to be starting up, so in an HTTP server, it creates an Express server. Express is basically a very simple web server system that allows you to handle, lets you handle requests through the system. Now, if it works for Windows is going to be a question. That is always a concern I have. App.posts mine request and response. Now, because these are essentially operations being handled by the web server, we have to make sure to list both the request being made to our web server and the response is being passed in by Express for us to call when we're done doing what we need to do. Const new block equals blockchain dot generate next block with the request's body data. We're going to blockchain dot add block new block, and we need a broadcast function, which I'm not sure I have. Oh no, I do. All right, that's not going to be a problem. We're going to broadcasts. Now, a lot of this shit is taking place outside the blockchain itself, and that's just kind of what happens. We'll refactor the code with time and move things into places where they need to be, but for now we're just putting out some basic code for well, let's hold off on the broadcast for now. We're not going to worry about that. And then res.sends. We need an app.get peers, which will allow our Actually, I should do this way. s.socket.remote address. Oh, this should be a backticked string, not a... There we go, template string. s.socket.remote ports. And that is all that needs to do. app.post add peer is going to need to wait, I forgot to set this to rec and res. Add peer is going to need a rec and a res, again request and response. And we are going to have a connect to peers function. And I'll add that in a bit, that's why I've commented it out for now. And then we res.sends. We just reply emptily. And then finally app.listen HTTP ports. Console.log listening for HTTP requests on ports. HTTP ports. And of course these should be backticks, not quote marks. And yeah. We now have a function that will start our server. We also are going to let init p2p server because we also need to server equals new server on ports, p2p ports. Server.on connection web server init connection. Now to fix this, we're going to console.log listening for P2P requests on ports. P2P port. Now there's a bunch of basic functionality functions I gotta get through to make sure this shit actually works. Stuff like connect to peers, response latest message. Possibly I should need to rewrite that. Well, first and foremost, we need a, we definitely need a broadcast function. Actually, hold on. Let's start with our init connection here. Let init connection equal so sockets.push yeah. This should be, there we go. Sockets.push, so we're going to add the actual connection to our collection of sockets. And we're going to init message handler with our WebSocket. We're going to init error handler with our WebSocket, and we're going to write out to our message sockets. No. Now, basically what we're doing here is we're just getting things set up. We're going to set up a message handler, which I'm going to write here. Let's init message handler. Which is going to set up a new function on message. When a message is passed to that socket, we are going to do some stuff with the data. Now I'm going to have to do a lot of cleanup of this code, which is going to be frustrating. What is your problem? Okay, yeah, any place we use that, we are going to need to... Unexpected dangling underscore in sockets. slint. What's the error called again? No underscore dangle. Okay, no underscore dangle off. That'll stop that from being an irritation. And I guess at the top of this page we can lint no console off. That'll stop that from being a warning. Reduce the number of supposed errors that I've got with these little wiggly lines underlining things. What's your problem? Assigned a value but never used is never reassigned. We can clean that up in a bit, but for now our message handler needs to do something with its data. Const message equals json.parse data. We're going to console.log. Yeah, it really hates using concatenation. I need to instead do it this way. Received message json.stringify message. And then we need to check on the message type. Switch message.type case message type dot query. Oh, right, we don't have an enum for that yet. So I need to actually create that. We are going to have types of messages. Const message type equals query latest 0, query all 1, and query, or wait, response blockchain 2. I don't know. No, it's not. So yeah, we have our message query. We are going to be querying latest tests, write response latest message. No, come on. What is your complaint here? Expected a default case, of course. Well, we're not going to have a default case. Break. Case message. Oh. Hold on. What did I name message? All uppercase. message type, just make my life easier. Query all. Write ws response chain message break and case message type dot response blockchain writes oh no, wait, handle blockchain response with the message and break case defaults. Oh no, just defaults. Default, do nothing. Don't need a trailing semicolon there. Do need a trailing semicolon there. Do need a trailing semicolon there. And a carriage return. Alright, so now let's init error handler ws.on error. Oh, wait. I actually need to create a function first. Let's close connection equal ws console.log connection failed. No, wait. Connection failed ws.url and sockets.splice sockets.index of ws1. Essentially all this is doing is removing that socket from our collection of sockets that are open. And from here, ws.on close, we are going to close connection. And on an error, we're going to do the same. This is all very, very simple, and for an actual running blockchain, this would not be the way you want to do it at all. You would want a lot more in-depth error checking, but for the purposes of what we're doing here, basically just trying to turn our blockchain of data into a distributed blockchain that can be verified by every connected peer. You know, for this demonstration, this will be the simplest way to accomplish it. Now I need to find, I have some missing functions, like this, connect to peers. Now that's a part of, right, rec body.peer. And I still don't have my broadcast message. I actually do need that. Connect to peers. Broadcasts. Response latest message. And we'll get to those in a second as well. But for now, we are going to make sure we can let connect to peers equal new peers dot for each peer where let ws equal new WebSocket peer ws.on open. We are going to init connection. I don't think have I defined init connection yet? Yes, I have. Okay, just making sure. My brain is not doing the best right now. Error. I guess that isn't completely unnecessary. I can just console.log connection failed. Connection failed. Yeah, I'm just gonna leave that as that for now. If I need more data later, I will put it in there. Hold on, did I fuck something? No, I did not. Alright. Now, we have some handle messages. We have let's handle blockchain response, which takes a message. Bear received blocks. JSON.parse message.data.sort b1 b2 b1.index minus b2.index. This will make sure that they are in the correct indexed order. Latest block received equals received blocks dot length minus 1. This will assure that we are grabbing the latest on the lists. Bear latest block held equals now there's a question. Do I have a means of... Oh, yes, I do. Equals blockchain dot get latest block. And now we are essentially going to do some validation here. If latest block received dot index is greater than latest block held dot index, console.log blockchain possibly behind out of date. Ah, shit. Again, templates. Blockchain possibly out of date. We got latest block held dot index. Peer has latest block received dot index. And there's that. So blockchain dot push oh no, well, now we need to see if we can add this block. If latest block held dot hash triple equals latest block received dot previous hash. I got a space in here in the wrong spot. Whoa. Well, it looks like we might have a console.log. We can append this block to our chain. Blockchain.add block latest block received broadcasts response latest message. Now, else if received blocks.length triple equals 1, console.log, we have to, I guess I can just do a normal string here. We have to query the chain from our peers. Broadcasts query all message. And failing that, hold on, actually that is else console.log received blockchain is longer than current blockchain. And we can replace, well, here's a place where things need to be paid attention to, because we're at a point where now we're talking about multiple peers communicating to identify who has the longest and most accurate blockchain. That's essentially what we're doing here. Each node acts like its own independent, untrusting server, right? It is doing all of the business logic for itself, and then it's going to be comparing with other peers that it has. In order to do this, our blockchain has to be able to do one more thing. It has to be able to replace itself with our blockchain has to be able to replace itself. Now, this isn't going to be tested at the moment, so we're going to have a ton of code that is completely untested, unfortunately. But that is quite alright, because if this dot is valid chain I need to change is valid change a bit. Chain equals null. If chain does not equal null, actually, if chain is null, chain equals this dot chain. And now I can remove this. Let previous block equal chain dot zero. Basically, just gotta remove all the thises from this function so that now let me rerun my tests, just to make sure I didn't just destroy this. Use object destructuring line 47. Assignment to function parameter, that's why. So, let test chain test chain else test chain equals chain. Now, what are you complaining about here? Test chain is assigned but never used. Right, well, we'll fix that in a second. Test chain. Test chain. Test chain. Test chain. Test chain. And we're going to delete that just so it doesn't throw any bugs. Now, logically, this should still work. Right? Waiting on you. Yes, alright, awesome. So now we can do our replace chain. So, in order to replace our chain, we need to this.isValidChain, chain, and chain.length is greater than this.chain.length. We are going to console.log is valid and longer than ours. Block this.chain equals chain and broadcast. Oh, we don't have a. We're going to have to do that broadcast later in a different function. Else console.log received blockchain is invalid. And that is all we need to do there. And we can write tests for that in a minute. However, for now, we need to actually replace our chain. Blockchain.replace chain. Received blocks. There we go. And now that's done. We gotta check one more thing. If the index is shorter, console.log received chain is not longer than our current chain, ignoring. There we go. And we have a way to handle interactions on the blockchain. Still have two problems. Where are those at? Control-Shift-M. Parsing error. Oh, that's an absolute error. Now we have a ton of shit that's tiny. Just style guides. Now where are we using those? Because I know I just fucked up. Where did we use those? Here. Oh, why were you at the hospital? I'm sorry. What happened? Initial peers is a value that is set but never used. I guess I should just go through and const all my functions because they're never going to get reset. Connect to peers. New peers. Alright. Those should not be vars, those should be constants. Never used. Broadcast is not defined. Alright, we are in need of a broadcast function. These are all just very simple one. Simple. Broadcast. Oh. Write. Send JSON.stringify message const broadcast equals message sockets.for each sockets write socket message. There, now we have, what are you complaining about? Unexpected parentheses around single function arguments having a body with no curly braces. Well, fine. I think it wants this to be on its own line, even though it's unnecessary to do so. Now we need a const query chain length message equals a very simple type message type dot query latest query all message equals type message type dot query all. My hiccups are quite bad this morning. Good lord, I'm sorry. Const response chain message equals type message type dot response blockchain. Data is JSON.stringify blockchain. Fine. What's your problem? A space is required before, okay. Pad that out. Alright, simple shit to fix. And we have like 25 little niggling bugs. What's your problem? Used before it was defined. Oh, alright. Well, let's just move these up then. No, I wanted to actually move those up. So we're going to stick these little tiny functions here up at the top. Const... I guess we don't need any more. Those are all those. I need to rearrange all this shit, don't I? So, init message handler was used before it was defined, so these two need to be bumped up. Sorry, just, arranging shit. Been waiting on a surgery date since 2016. Oh, good lord. Okay, not used. Response latest message is defined. Oh, no, it's not. I'm an idiot. This is response... Yeah, chain message. That's the chain message. And then I can just basically yank paste latest message is going to be blockchain.getLatestBlock. And that should fix that. Initial peers is assigned a value but never used. Wait, really? I know I'm missing shit. Oh. So we're going to connect to peers, initial peers. We're going to init HTTP server. And we're going to init PTP server. Alright, missing semicolon. Here. Connect to peers was used before it was defined? Really? Ah, that's why. Okay, let's move you up. X, no, D. Paste, Shift O, O. And then there's weird spacing somewhere I need to clean up. Alright, init connection was used before it was defined. Shit, my message handler and error handler need to be bumped up too. There is an order in which these things need to be done, and I have not done them in that order. Handle blockchain response was used before it was defined. That's interesting. Well, what are you? Init connection needs to be bumped up just a little bit. Handle blockchain response needs to be put up before. Where is handle blockchain response? There. Before line 48, so I guess we can stick that. Blockchain response, I guess I can just stick that here. No. Paste. And WS already declared in the upper scope. IWS, IWS, IWS. Sorry, just doing a little bit of bug fixing, because I'm kind of writing this shit on the fly. I'm not really... I'm using other people's code and then, you know, mixing and matching where necessary. Oh, shit. Because I really do want to show you guys just how simple this shit really is at its basest level. And what we're doing here, we're just making sure everything's cleaned up. IWS, IWS, IWS. Now, somewhere... Where? Oh... I'm an idiot. That wasn't necessary. Where in the hell? consts. Space required after something. Oh, okay. Just doing a little bit of cleanup so that I can see where my problems are. Alright, now we're clean. Let's see if this bitch runs. Roll up. Wait. Do I have a roll up? I've got a roll up config. It's basically going to make a dist bundle starting from main.js. But do I have a function for it in my package.json? No. Yarn built. Reference error. Using removed Babel 5 option, foreign modules. Use the corresponding module transform plugin in the plugins option. I haven't seen it do that before. Well, let's check my rollup config, because that is... Alright, let me see. Let's just copy paste this into my search engine in order to find out how I can fix this. Okay, just looking for a fix. Can't use modules equals false. Oh, this is from like a year ago. Plugins Babel exclude, yes. No, that's not it. Yeah, env modules false. Shit, this was working for me in another project. Oh. Frustrating. No. Yeah, resolve Babel modules. It's supposed to. Oh, that is so frustrating because I could have sworn it was working before. Okay. That is exactly what I have. Presets, env, modules false. When did this stop working? Alright, let's see what this tells me. Because everything they're telling me is what I already have. This is frustrating. Roll up C. It's going to throw the exact same error. Yeah. Even though it shouldn't be, because I've worked with this code a dozen times, and good lord is it fucking hot in here. Well, let's just use this as sample code for the moment, while I can't compile it. Just making sure, yeah. Okay, so, logically, I should be able to npx babel node source main.js. That should run, right? Please. I might have missing dependencies too. Oh, no, already up to date. Christ. That's weird. Roll up modules false. Reset env. Okay, yeah, it's telling me I shouldn't be... Yeah, removed foreign option, foreign.modules, use corresponding module transform plugin in the plugin options. So, do I want to... Latest? Okay, that could possibly be it. Let us see if that doesn't fix it. Env... Yes, 2015. Modules false. Oh, I don't need that. What's your problem here? Expected indent. Oh. Alright, now let's see if that does the trick. Nope. Well, let's see if using latest works. Yarn add dev babel preset latest. Yeah, it's telling me to use env, but env doesn't want to let me use modules false. I mean, it really should be... Don't make me use ES 2015 rollup. It's going to fuck with everything I'm doing. Huh, that's odd. Oh, I see what the problem is. Okay. Default not exported by node modules, WS. Really? That's interesting. Okay, so WebSockets. Can I do it like this? WebSocket is not exported by. Yeah, default is not exported by Express. Cannot call a namespace. Import Express from Express. Just a little bug fixing. Express is not exported by. Okay, ES6 importing Express. So your import line should be what? No? Yeah, I should just be able to import Express from Express. But apparently default is not exported by node modules express index.js. I've probably fucked something up. Severely. If I make the camera window larger, it's just going to make everything... I'm just going to block everything else I'm doing. Sorry. Seriously frustrating. I do wonder what's going on, because I should just be able to import Express from Express. Default is not exported by node modules express index.js. In fact, this should still be the same. Import WebSocket from WebSocket. I don't know how it gets past Express, but not WebSocket here. It's so weird. Anyway, I'm going to have to spend some time working on this, unfortunately. But essentially what we've done here, what I've been spending the last time doing, when it comes to a blockchain, and yes, I have no code running, so this is all just theoretical that I'm talking about, but when you have a when you have a node running, the node has to validate with its peers in order to build a collection of its own peers, its sockets. It then uses those sockets to communicate with all of its other peers and do validation. Now, how does this validation work? Well, we essentially are going through and passing around these messages, right? We have 3 basic messages: query for the latest block, query all the blocks, and a blockchain response. The blockchain response is perhaps the most complex, because chain message and latest message, yeah. All message basically just you know, chain message asks for your entire chain and returns it as a full JSON string. Latest message just returns a single block that is supposed to be the latest block on the chain, and then we compare the latest block that we have on our blockchain to the block that we've gotten from our peer. And we're going to be doing this with every peer in our set. So if I ran this 3 times with 3 different ports, if I could run it, I'm going to have to dig into why it's causing errors. But if I ran this on the same computer on 3 different ports, let's say 3000, 3001, and 3002, and I added a block to one place, once we connect first, it will identify all of the other, it'll identify all of its other peers, essentially just by communicating with itself. And then by communicating with its peers, it can update its list of peers. And then it goes to each list of peers every time it gets a broadcast message saying, "Hey, we've got a new packet, or we got a new block." It's going to go through and say, "All right, give me that block. I need to see if this works with my blockchain." And then it's going to compare the latest block that it was given to the latest block that it has in its own blockchain. And if it validates, if it works, okay, I will add this to my blockchain. And then it does a full validation when we try to replace the chain, just to make sure. And and in that case, suddenly our node gets updated with the longest chain. Someone else connects to the net. If someone else connects to, or opens up a new node anywhere, it will connect to its to us as a peer. It will add the rest of the peers from communicating with the server. That's what this bit right here is about. Basically, each server can list off, or each node can list off exactly what it is able to do, and all of its neighbors. And then we can add those peers and go through and check every one of them. Do you have a longer blockchain than I do? All right, let me compare these 2 blockchains. And this is exactly the same if you're brand new on the blockchain, or if you restarted your computer and just started your node up again, or if your phone is your node, etc., etc., etc. You are always going to have to say, all right, which of you I'm going to talk. So let's actually walk through this for a second, because this is actually really fascinating shit, right? So you've got this chain of data. It is validated against itself for every block on the chain. And for now, let's say we've got 3 items in our list. Suddenly we have, so someone, mines on our block, which is literally just generating a new block. Mines on our node. And then when we do, we send a message to everyone saying, "Hey, I've got a new block." Everyone else is going to be like, all right, let me check on this. Let me make sure this fits. If their chain is longer, well, their latest block is not going to match up with what we based our latest block on when it came point to mine. So they're going to say, look, I can't take this. And when they do, we're going to get that message back, and we're going to go, well, shit, their message is longer. It's time for us to validate against that peer. And then we validate, we see that theirs is longer and also matches our blockchain, the parts of the blockchain that we already had. So we can move forward. We replace our chain with their chain, and then we try again. We mine again, and we send out that block. That block is going to get validated by everyone else, and so long as all of our chains are in sync, suddenly all of us are going to add this block to our chain, and our blocks are going to be in sync again. More so than this, we're going to be seeing Now, what happens when you've got a malicious actor? Let's say someone comes along and says, I want to change this block so that instead of sending money, this person is sending me money. I want to basically rob them using the blockchain. Well, they come along, they set up their node, and they set up the node maliciously so that it flips the sender and receiver. As soon as it goes to broadcast that it has a new block, a malicious block, or even an accurate block, right? So let's say it is creating an accurate block, but it's changing data in the past history of the blockchain. Well, when we do that, it's going to validate against our latest block, and our hashes are going to be different because the data has changed. And once the data changes in one block, the hashes for every block following it change. And the network is going to just dismiss it outright. But what happens if 100 nodes are working in this malicious manner? They're working together to convince the blockchain that which is agreed upon is wrong. If you get enough nodes together, this system we've designed here together will absolutely break down. The consensus will be influenced by the person who has the most miners and the most influence with their miners, or nodes, or whatever you want to call them. Suddenly, you've got a split in the fork, or in the blockchain. You've got one chain that is going along, and it is validated by everyone. And then you've got this malicious chain, which has changed something in the past, but has essentially convinced all of the nodes in its malicious network that this is the correct chain. And now, new connections are going to be asking for peers, and they're going to get some of these malicious nodes. How does it distinguish which is better? Because so far, all we're doing is saying, are you longer? Well, if you're a longer chain, then you must be better. This is one of the huge problems that exist in very basic blockchains, and why cryptocurrency especially gets so complex so fast. The problem of consensus is very troublesome. Honestly, people didn't expect it to be solved before we had the computational mining solution, where you essentially have to invest electricity usage in order to assure that you have invested proof of work, as it's called, into the system. Hello, Anata. Glad to see you. I probably haven't explained this very well, and I've been going on for about an hour and a half just rambling about code and designing this when it's not even just wanting to work, strangely enough. Wait a second. I know what part of the problem might be. Double check on something. BabelRC false, yeah. Plugins, external helpers, env, modules false. Why is it hating me? I don't know. I'm sorry, I just had to look at that code again. I'm going to be working on it through the day. And of course, if you want to see the code as it grows, I actually have it set up on GitLab. Sevi toy blockchain. I'm going to throw this link into the chat right quick. You can actually follow me as I'm working on this code, whether I'm streaming or not, right here. And, yeah. Unfortunately, there's things I need to figure out. I do these programming streams pretty much off the cuff. I'm working with other code bases and just rambling on the subjects. They're very disorganized. I don't know why you watch them, honestly, although I'm very glad you do. Although not many people are watching this one, sadly enough, but whatever. Honestly, these, I guess we can call these research streams, programming streams, whatever you want to call them. They're not super interesting, I guess, and I guess they're a little bit confusing. I'm not sure how I'm going to do a better format for them. That's the problem. If I wanted a better format, well, I don't know. What do you guys think? I mean, you guys are the ones sticking around for this shit. I mean, I guess I could do write-ups on these different subjects instead of rambling off the cuff while programming live. I don't know. I guess I'm just kind of frustrated because I always run into a bug that I'm going to have to do research on, and doing that research is actually really irritating on stream. That said, we're getting closer to what a blockchain actually is in the modern day, which is more than just a string of data verified against itself. We're actually looking at a stream of data verified against itself and a system of nodes, software, that not only verifies the data against itself, but in a very distrusting manner, it pushes out and says, all right, look, I need to validate this information against your information. Are we in consensus? I need to validate this information against all my peers' information. Are we in consensus? And it tries to go and, you know, getting consensus by the longest chain just means that a person can add 1,000 blocks. And as long as the origin point of those 1,000 fake blocks is okay, matches, then we're okay, then we're solid. But if it doesn't match, you know, then these fake transactions are going to be, I mean, this has been a problem for a long time. This is what are called Sybil attacks, SYBIL attacks on Bitcoin. This is why people find it so easy to steal, you know, tens of thousands of Bitcoin, because they just set up enough nodes that are acting as miners, no matter how slow. And once they get the opportunity to mine, they inject 1,000 blocks into the chain instead of one, and then everyone sees this super long chain that has validity that can be, you know, and that chain has consensus with thousands of nodes who are in on the malicious attack. And this makes it a lot easier for people to steal from Bitcoin. Now, this is partially solved by the proof-of-stake algorithm, but I'm not a huge fan of proof-of-stake because it holds the same exact problems as proof-of-work, in that the person with the most money is going to be able to hold the most computing power for proof-of-work or invest the most in the pool for proof-of-stake. And we'll get into proofing algorithms in my next stream, because they're a very important part of how blockchain ecosystems survive. But for the time being, I am very, very overheated, and I would love to just take a 10-minute break, take a little break, figure out this problem, fix it in the code, and I might start another stream, I might not, I'm not sure. But I will definitely catch you guys tomorrow for more streaming. Mwah. Thank you for watching. And by the way, I just want to give a quick shout out to Kaho-chan, Arakeen, Anada, Lady Justice, Stembolt, Vladiro, and Gypsy for sticking around during the stream. Thank you guys so much. I know that this is extremely nerdy and over a bunch of people's heads, but it really does matter to me that you guys are here, that you guys are following my streams, because it's been an uphill battle. YouTube absolutely hates me. Patreon hates me. I'm getting to a point where, because of my more conspiratorial investigations, I am gaining a bad name with most of the social networks. And because of that, I mean, I need your support. I need you guys here showing that people are sticking with the material, showing that there is demand for the material. It's you guys that keep this going, and I thank you all so very much.